Hello everybody, and welcome back to the Laser Matrix engraving channel, where have been doing a series of videos regarding the Chinese K40 40 watt brackets 20 watt laser system. So I've been going mostly in this series. I've been delving into a lot of the maintenance of the machines, but I think after this I'm going to end this part of the series here in regards to the beam alignment, and then I'm going to be getting into more application based things. So, but today is alignment day. And just for future reference, when we do move on into applications and materials, if you do have any type of a question, I might throw out a video explaining what I know about certain issues. Just leave them in the comments. But yeah, today, beam alignment. It's good to kind of get a better knowledge of what parts I'm referring to. So I'm going to go through that real quick. When I refer to the arm, the rail is what I'm referring to. The focus carriage is what carries the focus lens and the number 3 mirror. And then we have the number 2 mirror. And way in the back there is the number 3, or is the number 1 mirror. So when we say beam alignment, in order to get the best quality in your engraving and the most power, it's important that you have a beam alignment that is coming straight through directly from the number 1 mirror to the number 2 mirror, then from the number 2 mirror to the number 3 mirror, and down through the lens. And you might say, duh. Well, it's important to understand the aspect of this. You know, you want it to be coming in straight through in straight lines, but what you may run into, and I understand that these are considered cheap machines, but when it comes to doing alignments on these laser systems, it's good to have a lot of adjustments, a lot of adjustment capabilities. With these machines, you don't have a lot of accurate adjustment. The number 1 mirror, for instance, sits on a bracket that you can slide front to back, and it's got a lot of play in it, so you can move it side to side. But you really don't have an option if the beam is hitting low on that mirror other than moving the entire laser tube up, which is what I had to do originally with my laser system. I actually had to get behind there, and the laser tube has plastic straps on it, or plastic brackets, and I had to put some shims, some plastic shims in there to kind of lift it up a little bit. When it comes to laser movement, you don't usually want to do a lot, because a little bit of movement makes a big difference in how much the laser moves. So you want to do it in little small increments. But so I had to do that on this laser and shimmed it up a little bit. And even with that, I'm still hitting a little bit low, I believe, off center. But when it comes to the issue of beam alignment, what you want is, ideally, you want the beam going directly in the middle of the lens and down to your work. But with these, it's so hard to do. If it's off slightly, off center, that's not necessarily a completely bad thing. If it's more towards the center than towards the outside of the lens holder, the area where the beam goes through, then that would be considered okay. You're not going to lose a lot of power through the lens if it's off slightly like that, which is what mine is off slightly, because I really don't want to mess with it a lot. You know, I've got it fairly decent, but I'm going to go through this with you just to kind of show you. Okay, so we're going to start at the number 2 mirror, which is on the left-hand side of the arm, or the rail, the focus rail, sorry, the carriage rail. We're going to start here, and this is assuming that the beam coming from the number 1 mirror to the number 2 mirror is in a relatively straight path, okay? So we're just going to say that, oh, it's already good. So we're going to remove the ring. And we want to be careful not to drop the lens. I'm sorry, the mirror. I'm having a rough time today with my words. And I'm going to go ahead and put this mirror holder back on there without the mirror. Okay, now this is where you're going to have some masking tape. So I just cut off a small piece like that, and I'm covering the hole, the aperture where the beam would come in before it hits the number 2 mirror. And if you look at it, you can kind of see the outline of the aperture there. So when we go to burn, we're going to start at the back. Always start your first burn, which is what I call the reference burn, at the very back of the machine where it first comes out of the hole for the number 1 mirror. And so I'm going to do that. All right, before we do that, we want to make sure that our power is set low. Ideally, you want it to be around 4 or 5, and I have mine figured out already. So I'm going to put it down a little bit below the 5, I think. Okay. Okay, and then, well, I might as well show you this too. So we want the laser switch on, because what that does is it provides power or current to the laser tube, okay? Machine's on, obviously. This test switch right here is what will fire the laser, and it keeps on firing until you let up on the test switch. So if I hold it down, it'll fire, let up, and it will turn off, okay? So that's what I'm going to be doing. So I'm all set. I'm going to hit the test switch. Okay, let's look at it. So here you can see where it's hitting on the mirror. It's low. And again, that's not ideal, but let's see what it gets when we have it back here. Okay, let's try it. Okay, so we're off just a little bit. It's off to the side. So because it's off by so much, I'm gonna go ahead and adjust that. And what we have for that is these two. I believe it's these two, but I might have to play around with this for a second. Okay, so let me do that and get right back with you. Now we bring it down to the front. And let's see how close that beam matches up to that spot. It's right on top now. Okay, so what I did was I adjusted this corner screw right here for left and right. Okay, and I think the bottom screw is what adjusts up and down. Okay, so now we know that we've got a good alignment straight across there. Let's see where it's hitting on the other mirror. But we'll have to take this off. Okay, so now I've got the number 2 mirror back on. Let's loosen this top screw here. And we'll take the number 3 mirror off. More tape. And I'm going to do the same thing. I'm going to put a piece of tape over this. But before I do anything, I want to remove the lens, because the smoke and tape residue will flow down on top of the lens. Okay, so that's out of the way. Start it over here. Always make your reference mark closest to the mirror, to the path that you're testing. Okay, so it's going to, these two are going to be the closest for your reference. So let's take a look at it here. Okay. And then we'll move it back. Let's take a look and see where. So that's where it's at. You can see, hopefully, I don't know if you can or not. Yeah, there you go. So you can see it's slightly high. It looks better actually than it does on the number 2 mirror. So you know, they're probably not exact perpendicular to each other, but so we see that it's good there. Now we're gonna go ahead and we're gonna test it in the far field. And there we see that the beam is a little bit low and off center there. So we're gonna have to walk it. And what I'm gonna be doing is adjusting these screws in the back of this mirror here. So side to side, I'm gonna guess, let me I'm gonna guess that the side to side is let me think here. Maybe this top one. So I'm gonna move it. I'm gonna. The beam needs to move over a little bit. I believe that's what it was, right? Yeah. So I'm going to move this out just a touch. Let's see what it gets me here. Moved it slightly, just a little bit more. Okay. Let's try this again with a new one. So we'll come back here, make our reference spot, come back here, pretty close. So just a little bit more maybe. Looks like we're really getting closer, doesn't it? Okay, I'm going to try moving this one a little bit, tightening. Let's see if it moves it slightly. I think we're getting pretty close. Okay, I put a fresh piece of tape on, make my reference burn. Let's move back this way. We see our little reference burn there. Okay, just slightly too much, so I'm gonna go ahead and loosen that a little bit. Let's see if that brings it back this way. Okay, I'm gonna tighten, loosen. Let's see. Tighten this a little bit more here. No, loosen. Yeah. Okay, let's see. Try this again. Reference burn. And that's right on top of it. Okay, so that's our alignment through those two. Let's move on to the number 3 to the lens. So I'll put the number 3 mirror back in. Okay, so what I've done is I've taken the lens out of the lens holder and I've placed a small piece of tape on the bottom of that. Okay, I've got my lens, I've got my number 3 mirror back in. And I'm gonna go ahead and make my reference mark here. Okay. Now we're gonna move it back this way, make our mark here. Okay. Okay, so on mine, you can see that it's a little off center, but I would still call that good because it's more towards the center than towards the edge of the outlet hole there. So if I wanted to really, you know, if I was seeing any engraving issues in my work, then that's the first place I would, you know, go to repair this, is to actually get a better spot position. But being that this is what it is as far as this laser goes, you know, you don't want to you know, go that deep into it, dive that deeply into a beam alignment, man, because you're gonna find it's a pretty tough thing to do, because that laser tube is gonna have to, depending on what your laser is doing, but it's probably gonna have to move up or down you know, if you've got that situation. But yeah, so anyway, that's how you do a beam alignment. It's pretty straightforward. Just when you do them, always remember that when you're testing, your first test mark should be closest, the mirror should be closest to each other. So 1 to 2 towards the back, move forward, do your test burn here in this position, and see how far off you are on your alignment there, front to back. Once you have that established, two mirrors close together, number 2 and number 3, make your reference mark, then your cross field mark, and see how closely they're lining up. Adjust that there if you have to, and then test with your lens holder. Okay, pretty simple, huh? Yeah. First beam alignment is always the funnest, but that's basically all there is to it. And when you're done with that, run a file, and let's do that. Let's see what we get. Okay, so now we're all set. The lens and the mirrors are all put back on. And before I get to this setting of the file, just wanted to point out that the reason I say that that beam alignment that I just showed you is good and it's okay is because this is such a short laser engraving field. If it was a longer, say 48-inch long field of engraving in the X direction, and whatever it would be in the Y direction, I forget what some of these are now. What is it, 48 by 24 or 8? I don't know, something like that. Anyway, if it's a longer path that the beam has to take, you're going to lose power along that engraving axis. The farther out it goes, that's where your beam alignment becomes more critical, is the farther out you go. But with these short field laser systems, you just need to be close, and it's good enough. Okay, so I just wanted to get that out there. Okay, so I'm ready to run a test file. I've got everything back together. I'm going to be sending a vector cut, and I'm going to do it in a dotted line. I hope it comes out that way. But I'm doing it as a dotted line, and that was hopefully give us a good indication on how this thing is aligned. So I don't want too much power with this, and I think right about where I was doing an alignment is going to be good. So I'm going to try it. Might have to raise the power a little bit, but we'll try it and see what happens. Okay. I'm doing this without any air assist, and just the blower on. And as you'll recall, on my alignment, it obviously wasn't exactly centered, but it's not showing any of the effects of it. One of the reasons too is because of the lens. It's a plano convex lens. Oops, went off a little bit. It's a plano convex lens, and it's probably close to like a 2.0 lens. It's a multi-purpose lens, which means that the focus point is a lot more forgiving than say a 1.5 lens. So the shorter, or the lower the number of the lens, the shorter the focal point. And of course, they use the shorter focal point as a high definition because a high definition lens, which will make your laser dot smaller, and you'll get finer detail out of it, and the energy is a little bit more intense too, but it's not as forgiving. You have to be pretty close to right on in your focus point. But so here it is. Yeah, it's pretty darn good. I mean, the detail on the smaller stuff is really good on the thinner lines, like the beak and the head feather. And you can compare that to what's on the computer there. You know, there's not very much meat to it on the file, yet I'm still seeing that head feather. And I used a dotted line, but I guess it was a little bit more power than I actually needed. But I didn't really have it that high. I had it less than 5 watts, so it didn't really require a whole lot. But yeah, that's the whole story, with a simple alignment from the number 2 to the number 3 mirror. Hopefully you won't be intimidated to do this. It's not as hard as it might appear to be, but you know, it's just part of the game. It's a necessary evil that you have to do every once in a while, because there's a lot of motion on these, a lot of vibration. But just a little bit of work and I'm up and running again, and everything looks great. Couldn't ask for much better. So I hope you enjoyed this final maintenance installment. If you have any suggestions for a different maintenance issue that you'd like to see tackled, I'd be happy to give my 2 cents worth on it. And so I guess that's it. I will see you at the start of the next series where we go into applications. Thanks for joining me today, and we'll see you next time.